Good afternoon. I hope everyone is doing well. My name is Sorin Bularca from Autodesk Middle East, and I would like to welcome you to the third session of the day of the 2020 Value Engineering Summit. The digital event is brought to you by Middle East Consultant and Big Project Middle East. This presentation will be for about 10 to 15 minutes, following which we will take questions from the audience. So viewers, please feel free to drop your questions in the chat box with your email address. So if we are not able to address them during the 8 minutes Q&A session, we can contact you after the discussion. And also please keep your questions brief. So just allow me to share my screen and we can start to go into the presentation mode. So, okay, I hope you can see my screen. So the topic for today will be generative design and how it can help us with value engineering. I am the technical sales specialist for connected BIM and computational design at Autodesk Middle East, and I have a master's degree in structural engineering. My expertise is on helping companies in the architecture, engineering, and construction sector to adopt technology like digitization, cloud collaboration, and automation. During the session, I will be talking about how generative design can change how we design buildings by quickly generating thousands of design alternatives based on predefined goals, constraints, and inputs that will result in higher performing options and data-driven decision. We can take a look at the agenda. We don't have a very long agenda because our time is quite limited today, but it's quite comprehensive. So we will look at the AEC context and the technology evolution. Also, computational design and visual programming, some techniques that are the prior steps, let's say, to generative design. We will take a look at what generative design actually is, and of course, how we can use generative design by using value engineering case studies and some examples that I will show. So traditionally, the way of delivering buildings was to record the design intent on paper. Now, if we break down the design process of a building, it's actually different specialists sharing information with each other, and the end result of that information is basically the building itself. Now, when we started to build the first time, we didn't have computers. So the easiest way of sharing that information was using paper. So our intent is to capture what's in these people's heads and share it, basically. The problem with the traditional design process, in the paper-based process, is that it's like a trial and error. It's like a battleship game. Sometimes when we are deep inside or almost finished with the design process, we might realize that the materials that we've used might not be available, or we might notice that it's too expensive and the solution that we've designed is too expensive. So we have to go back to the drawing board and start from scratch, and we have to waste a lot of time to recreate the design process. So this is quite an inefficient way of designing buildings. Now, computers basically stepped into to help us, and software and computers basically can help us make this process more efficient. And we can see that in the last decades, we can see an accelerating growth of the technology development. And starting with CAD, which was a disruptor and basically allowed us to change from paper to digital processes. But the means of changing the information, the concept remained the same. Now things have dramatically increased in efficiency since we implemented BIM and also computational design. Also, what I wanted to highlight here is that these are the prior steps to generative design, and it's important to be mature or go through them in order to get the fruits and the benefits of the generative design. technology. It will be very difficult to jumping from CAD directly to generative design. I wouldn't say it would be impossible, but if you would really like to control the process and get the best benefits, you should go through all these steps. Now, automation basically is the new normal, and it's all around us, not only in the construction industry. And we have recorded basically, and we are noticing gigantic leap of automation in the construction processes and in the design especially, with the help of visual programming. So basically, visual programming is still programming, but it's instead of using code, it's using nodes. And so it's a node-based programming which allows architects and engineers basically to create their own automation. So visual programming is basically simplifying a lot the automation process by allowing us to create faster automation without having to go through all the syntaxing and coding. And with computational design, basically, we can add rules via visual or scripting interface, and we can also extend to other application. And we are building a system, not just a model. And the inputs for the systems can change, and we can immediately have another design option in a very quick and efficient manner. Just to show you an example of how this can be useful, computational design, for designing a stadium ball structure. Typically in a design process, the architects, the engineers, they are more concerned about the aesthetics, the resistance of the structure, but it's very difficult to assess the material waste. And we know that steel beams, they always come in stock length of 12 meters. Using computational design, basically, we can calculate the material waste for each design option. And in this way, we can do value engineering, and we can understand which design option has less material waste. But still, this process is quite fast and automated, but we can still consider it as a passive process, because for each design option, we need to press some buttons, we need to evaluate them, and it's still a kind of a manual process. A very good example of how computational design is basically helped for value engineering. It's the Museum of the Future here in Dubai. It's almost completed, and the designers, Bularca engineer, basically, they used computational design to reduce the number of nodes. Basically, this will reduce the buildability costs, material, the structure weight also will reduce the cost as well. Also, they wanted to keep in the same deviance from the design intent. So they managed to create several options, which they managed to evaluate, and with this, they register significant reduction in cost by using this technique. Now, generative design. Generative design is a form of artificial intelligence, and it's dedicated to create better outcomes. And it can be used not only for buildings, but it can be used for infrastructure, for systems, and it can be used for manufacturing. The principles of generative design come actually from the manufacturing sector. And it allows users to set the intent, apply the factors, and simultaneously explore and evaluate many design solutions. So I will emphasize here on one word, which is simultaneously. So we are starting to use computers in a more efficient way, and this can bring us a lot of efficiency in the process. Now, the difference between computational design, where we initiate the process, we have some data, we generate some design options, and we evaluate them. In generative design, basically, we can have a closed loop where we can evolve these design processes, and we can let the machine come up with thousands and thousands of design options. And our role as designers will be to select and filter the designs that are most suitable to our initial goals. So that's generative design in a nutshell. Now, there are a lot of examples and a lot of benefits. This technology is still in an early phase, and there's a lot of ideas coming regarding how it can be used. I will show you some of these ideas in some cases, some of these case studies. And I will start by introducing you Weinweinen, which is one customer of Autodesk. Basically, they used generative design in order to maximize the solar energy gain for their design options, and to maximize the backyard size and the views for their housing, and optimize cost and profit. They are a developer, and they noticed that they have a very low profit margin, so they wanted to use technology in order to increase that profit margin and to reduce the cost of their designs and their buildings. So the first step was, as I mentioned before, was to adopt BIM. So basically, they went through digitizing the processes and moving towards BIM, and they didn't stop there. Basically, they started to think more like a automotive manufacturer, and they started to develop modular concepts for housing. They started to build these families or these building blocks that can be assembled together, and they can create a house in a very quick manner. So basically, they invested in a building catalog of component parts that were used in the manufacturing process to build these components better. These are some examples of the panels that are using they are using, and they manage basically to reach a stage where they can assemble a house in 3 days. So next, what they wanted to do is to look at how they can optimize the design process. So that's why in around year 2018, they reached our research team at Autodesk. And we basically helped them develop an engine that was able to generate 15,000 design options, from which they were able to choose the best one based on goals and constraints that were initially put in the system. This, I wanted to emphasize on this example because this became the seed, basically, of what is today generative design from Autodesk. It became like a product that is rolled over, and customers can use it. This is an outcome of these different designs. So these are the parameters that they focused on for each design option, and these are generated automatically, so you can immediately see which ones are responding to the needs of the customer. Another good example is our Toronto office. Basically, here we did an exercise, and sometimes value engineering it doesn't necessarily mean cost. For this example, it was the goal was to create the best office based on employee preference, and we engage again our Autodesk research team, and basically what they've done some surveys with all the employees that were supposed to work in those offices, and the value drivers here were productivity, collaboration, and buzz. Increasing these three factors, these values, basically will create an office space that will be the best suited for our goals. And these goals basically branched out in other goals. And in the script and the system that the research team has created, they focus on these 6 goals, because generative design won't do everything. You have to have a limitation of the goals that you're putting into the system, and you have to strike the right balance between the what you want to achieve and what are your goals. We had also some constraints as well, and basically after we put everything together, this is the algorithm generating design options. The blue ones are the meeting rooms, the yellow are the desks, and each design option has a score. And basically, the algorithm started to generate thousands of design options. And once we were able to have these design options, the next step would be to identify the ones that are the most suitable to the survey results. We selected 10 design options, And then from those 10 people, basically, they voted for the winning design. And this is the winning design, which was very interesting. It was the first layout plan designed by humans with generative design. For fabrication, also, we have some interesting example of value engineering. This was an example that we've done for a facade. Basically, here the goal was to reduce the planar deviation of each panel, because this will translate into higher constructability. Also, we were able to check the panel rectangularity for each design panel. So just to give you an example of how the generative design engine looked like, we were basically able to colorize with red the panels that are custom, and we were able to generate some hundreds of design options, out of which we managed to identify the design option that has the least custom panels. So in this way, we managed to reduce significantly the fabrication cost by limiting the number of custom panels. Also, computational design gives us access to a different kind of optimization. In this case, is a solar installation study where we can simulate the impact of light on a facade, and based on the absorption, the light coefficient of the absorption in different locations, we can open and close the facade panels. So these panels, they have some openings, and based on the shade and the light scores that we had, we can basically generate a facade that can respond to those factors. In this way, we were able to create a sustainable design where we can reduce basically the cost of energy. In construction, and I'm gonna shortly complete the presentation, we have an example for optimization of cranes. Basically, this is an example which allows us to position the cranes and to find out what's the optimum way of positioning some cranes around the construction site in order to have maximum lift score, and in order to find how these cranes can be positioned, so we don't have to change the position at a later stage, so to maximize also and reduce the cost. Generative design can be also used for civil engineering. This is an example of analyzing the shape of the existing ground and creating the cut and fill for existing grounds by just generating thousands of design options without even breaking the ground. These are all some examples. They are out there. You can find online plenty of other examples. And just to sum up the benefits, you can do more iterations and more possibilities. You can eliminate the tedious and time-consuming aspects of a project. And also you can reduce waste. These are some workflow benefits. Of course, there are a lot of business benefits. Increasing customer satisfaction, which is one of the most important. Reducing project costs with life cycle costs with data-driven optimization. So we can optimize the construction cost with data-driven decisions. I just want to share with you one learning resources, and it's very easy to remember, generativedesign.org. And with this, we can move and take some questions. Just let me see how we are with the time. Okay, so we have a first question here. Can AI and generative design ever truly replace the human element during the value engineering process? That's the first question. So my answer would be no. This is just a personal answer, and it's just an assumption. We don't know exactly what will happen in 10, 30, 50 years. So I cannot give like a definitive answer, but I think my perception is that generative design is very good for one thing, and that is calculations. Humans are very good at another thing, and creativity, and humans have other skills that machines don't have. So I would say we cannot eliminate one or the other. Can generative design help with material selection on structures with unusual design shapes? At the moment, there is no out-of-the-box solution that would allow you to do that, but this can be developed. I mean, if you know the algorithms and if you can build up a computational workflow, to simulate that, you would be able to do that. Can generative design and AI help in optimization of the supply chain? That's an interesting question. I think if you have the data, you have the resources available, and you have already done some research of the supply chain, it would be easy, basically, to create a simulation on the supply chain and on the offers that they have on. So it will be something that it definitely can be done. What are the tools or libraries a design firm needs before they get into generative design? I was sharing with you the generativedesign.org website, and this will give you a lot of answers on where to start and what do you need. That's the best resource you can get for how to adopt generative design. If specifying similar parameters, is there a danger that AI will provide design options that are similar and identical? Yeah, I wouldn't call it a danger. It's so generative design is a tool, is a process. Okay, so tools and processes are subject to failure, but humans are there to drive these tools and make them better. So, of course, when you generate thousands of design options, maybe let's say 1,000 design options, 999 will not be used, will be wasted in a way. We can say they are wasted. But the result of those 10,000 or 1,000 design options is that it helped us identify that single design option that worked. And we can generate 1,000 because we don't have to work on those. The machine will do it. So that's how you should look at it. It's a tool that can help you. Will we be able to use AI to fully automate the design and build of a building? Yeah, for my personal answer to that question, I think we will be able, because if you think about in manufacturing, that is already possible. Construction is a bit more complex in a sense, but we are seeing a lot of manufacturing techniques being brought into the construction sector. And if we manage to sequence them and we manage to create some algorithms that can simulate this process virtually, we might be able to do it even in reality. So probably in the future, I don't know how far that would be. AI will be able to automate the design and even the build, so it will be the same like a manufacturing process, and it's already happening actually in some cases. What are the hardware requirements for your generative design system? So requirements are basically to have an up-to-date laptop or computer, basically, that can handle software like 3D BIM software, like let's say Revit. That's enough, because what our generative design engine is made is basically doing the processing in cloud, using the cloud. So it takes the burden from your desktop, and it's sending that burden of calculating and generating all the design issues in the cloud. So that's something that is very good. Does Autodesk support and educate new graduates with the right training to keep up with the market. So we have several educational programs, and we are working also with universities all across the world. We are also providing free software to all the universities and schools in the world. So if you are a student, you can subscribe and you can use any of our products. We are also doing trainings sometimes with universities, and also we have a lot of online libraries, so you can learn by yourself in your free time. There's a lot of YouTube videos. There's websites like Autodesk Design Academy. So Autodesk Design Academy, it's a very good library to learn new software. For generative design, you can use generativedesign.org. Okay, so for more questions, please feel free to reach out. You can reach out to me at my email address. So thank you for tuning in. I hope you found the session interesting and informative. Please join us tomorrow morning at 10 a.m. for the third panel of the 2020 Value Engineering Summit, which is centered around the benefits technology can bring to construction firms and to their projects. Thank you and have a good day.